Hello, and welcome to this video tutorial on how to use the SESConverter application. SESConverter can be used to convert CAD-based DXF or DWG files to a format that can be read by SES applications. In other words, the SES Input Command Language, or cycle. SESConverter can also export various SES cycle command files to a DXF or DWG format. In this tutorial, we will cover the main features of the application. First, we will see how to convert CAD files to SES F05 files, a process which we will refer to as an import. Then we will do the reverse, or an export. Finally, you will learn how to work with CAD Editor X. Let's start by launching SESConverter. Locate the SES software folder on your desktop. Double-click it to open it, and then open the Tools subfolder. Look for the SESConverter app and double-click on its icon to start the application. The left panel of the main window is the Data Input and Options section. The right panel shows the CAD viewer as well as the CAD Editor X interface. Now we'll see how to convert a CAD file to an SES format. Select DXF DWG to SES from the Convert option drop-down list. Also, select the desired CDEX file type from the next drop-down list. The MALT, MALS, and HYFREC types are available. Here we're selecting MALT. Next, specify the source and target file names. Then click the Browse button to access the Open dialog window. Navigate to your file. Here, insert bilayer l1off.dwg from the software's example folder and click the Open button. The file will load, and at the same time, an output file name will be automatically suggested in the other text box. Note that the program informs you that the drawing units in the input file are millimeters. SESConverter lists and displays all the layers, entities, and blocks contained in the file. It is possible to select or discard any of these objects so that they be included or excluded from the conversion. The Layers grid displays the content of the input file, organized by layers. The Radius column shows the values that will be assigned in the output file to the conductors of a layer. By default, the radii will be set to 0.007 meters, as shown here. However, it is possible to override this default by defining a mapping between the color of layers and a chosen radius value. This is specified in a so-called DEF file, which can be created and edited in the Color Radius Mapping window, accessed from the Settings window. In this window, you can add and modify entries to create a mapping of your own. You can also click on File Open to load predefined mapping files. For instance, this test DEF file, prepared for this video. Click OK to close the Settings window and return back to the main window. We can see the radii have changed in the layer grid according to the mapping we specified. Another thing to notice on the Layers tab is the Display Invisible Layers checkbox, which will enable the listing of all the layers contained in the file. The corresponding Export and View Invisible Layers checkbox enables their display and conversion. Checking the box in the Convert column heading will select all layers to be included in the conversion. Checking off the boxes in the individual cells will exclude a layer from the conversion. Similarly, to control the display of the contents of the layers in the graphical area, check the Show box in the column header on the right side or control them individually from the cells. For instance, turning off Layer 0 hides it from the image in the right panel. Now click on the expander Entities in Selected Layer. A table appears that lists the DXF entities that are located in the selected layer. For example, in the selected layer 0, there are 3 lines and 1 insert called B0-1. Checking the Convert All Contents of Inserts in Selected Layer box gives more control over the display and conversion by entity. Click on the Entities tab. The grid displays the contents of the input file, organized by types of DXF entities. Moving on to the Blocks tab, another grid displays the DXF blocks that are defined in the file and that are inserted somewhere in the drawing. click the Load Block Pictures button to get the block images. You can also see the contents of the block by expanding the Entities in Selected Block section. Now that we have reviewed and selected all we wanted from the input file, click on Convert to start the conversion. An SES-compatible input file, also known as an F05 file, is created. This file can be loaded in SESCAD, CDEGs, or other relevant SES applications to continue setting up the desired simulation. Next, we are going to describe how to convert an SES F05 file to a DXF or DWG file. Select SES to DXF from the Convert option drop-down list. Then click the Browse button and locate the file you want to convert. Here, the file we will use is mt_multipleburiedstructures.f05 from the examples folder. Click Yes on the Reset DXF file name dialog to update the output file names accordingly. As before, the system of units to use in the input file is shown here, meters. The export from SES Grid lists the various items that were read from the F05 file and includes conversion specifications. Open the Settings window for additional control over the conversion. In the General tab, uncheck the Convert Units box. In the Color to Radius Editor window, we can select the color that will be assigned to the conductors of a given radius. Since a DEF file of the same name as the input file already exists for this example, we can see that the mapping list is already populated. This data can, of course, be modified. In the Export tab, we can select the units for the output file. Let's select feet from the drop-down list. And then we'll click OK to close the window. Now that we have set all the data for the export, click on the Convert button. The confirmation pop-up window informs us that the DXF file has been created and shows us that 35 lines have been created in it. The result is shown in the drawing in the panel on the right. Next, we are going to introduce how to work with CAD Editor X, which is a powerful add-on tool that can be used in the context of an import, as part of an intermediary step whereby 3D solid entities, which cannot be read by SESConverter, are converted to another type of entity, such as 3D face, so that the resulting CAD file can then be read by SESConverter. CAD Editor X can also be used to view, create, and edit drawings, and it can load or save such drawings in multiple industry formats. We begin by selecting the Convert option, DXF DWG to SES. Then we click the Browse button to load a file containing 3D solids, here the 3dsolids.dwg file from the examples folder. We can see there are 3 solid 3D entities in the file. Since SESConverter does not natively support these, we can't see them in the View panel on the right side of the screen. Click on the Open and Export File to CAD Editor X button. The corresponding tab appears, and we can now see the 3 objects. Click SW Isometric for a better view. Selecting one object, you can confirm it is in fact a solid 3D entity by referring to the Properties window. Clicking on the Export from CAD Editor X to Converter button saves the current file in a format where the 3D solids have been replaced by 3D faces, which are supported by SESConverter, and it loads this file back into the main application. The 3 solid 3D entities have been replaced by 3 inserts. After the conversion, a message box will appear confirming that the F05 file was created successfully. Thank you for watching this video. Please don't forget to check out our online help, where you can obtain further information about the SESConverter application.